video on equilibrium, we are going to learn to write the balanced chemical equation for the given ionic solid in equilibrium and its aqueous ions. We are going to write the KsP expression for the chemical equilibrium equation. We're also going to use the given aqueous ion concentrations for a saturated solution to calculate the value of KsP. KsP is the solubility product constant. And in equilibrium, it's between a solid and its ions in the solution. So let's take a look at how this would be solved. If we have copper sulfide, a solid, and we're wanting to first write the balanced equation, we'll write the equilibrium yield sign as this, or we can also write it out, arrows in both directions. It's going to dissociate into its ions, which are copper, excuse me, 2+, and that's in aqueous form. Remember in class I showed you that we would have a beaker and the ions would form, there you go, copper 2+ for one of them. And we know it's copper 2 because sulfur is -2. We crisscrossed. We knew that that charge was a -2. And so our balanced equilibrium expression, they're balanced, would look like this. So in our beaker of aqueous solution, that's what we would have. Then we're asked to write out our KsP. It is the products over the reactants. However, solid is not included in part of our K expression. So for our K expression, we would write copper. It's balanced at 1 mole, so we leave it like this. We have sulfur, and that's balanced at 1 mole. Then we leave it like this. It is over 1 because a solid is not included in our KsP value, or expression rather. And then the final portion, we are using these values to solve for KsP. So I'm going to plug in the values of copper, 1 times 10 to the -18th molarity, concentration. We learned that from last unit. And the concentration of sulfur ions is 1 times 10 to the -18th. You can use your scientific calculator, remembering that in order to get times 10 to the 18th, you can go second function, comma, which is the EE key. And when you multiply those, you get an answer of 1 times 10 to the -36, and the unit is molarity, concentration. So we've completed A, B, and C for that first problem.